This is an AS Further Statistics 2 question on using the product moment correlation coefficient, or the PMCC. The scores achieved on a maths test M and the scores achieved on a physics test P by 16 students are summarized below. So you've got the sum of M is 392, the sum of P is 254, sum of P squared 4748. SMM is 1846 and SMP is 1115. Part A, find the product moment correlation coefficient between M and P. Now I've started off by writing down what's in the formula book for finding the PMCC. Now it would make sense to take M as X and P as Y, because then this would become SMP, which I have, and this would become SMM, which I also have. I will just need to work out SYY. So I'm just going to write down that the X for the formula in the formula book, I'm going to replace with M, and Y I just replace with my P. So rewriting it with M and P, this is how I'd find the PMCC. So let's just replace what values we have. So SMP is going to be 1115 over the square root of SMM, which is 1846, times by SPP, and then from the formal book that would be like SYY. So what I want is the sum of P squared, okay, which I have here, which is 4748, minus, so we'll need to put this in brackets, the sum of Y all squared, which is going to be the sum of P all squared, so that's 254 all squared over N, and N is 16. So we'll just evaluate that. Let's just make my fraction line a little bit longer there, and my square root all the way over here. So doing it on my calculator, I get R is equal to 0.9700147, so on. So we'd give that to three significant figures. So R is 0.970, so 3SF. Part B, we want to find the equation of the linear regression line of P on M. Now the formula book gives the line as Y on X, so just as I said before, my P will be my Y and my M would be my X. Now if in the previous part I had made my M equal to Y and my P equal to X, and I was able to get all the values, I would still get the same correlation coefficient, but I would need to make sure that I get them the right way around when doing the equation of this regression line here. Now the formula book has these for us in terms of X and Y. Remember, we need to change these to M and P. So B would be equal to SMP over SMM. So we have both of those, so that will be 1115 over 1846. Then to find A, that will be basically the mean of P that goes here, so that'll be the sum of P over N, so that'll be 254 over 16, minus B, which I've just worked out here, 1115 over 1846, times by the mean of X, which is like the mean of M, so that'll be 392 over 16. So my value of B will be 0.604008 and so on, and then my value of A gives 1.07678 and so on. Now I'd want to give these to three significant figures, So I can say that P is equal to A, which is 1.08 plus B times by M, because that's like my X. So my B is going to be 0.604 M. So I'll just highlight that. And I'll just put down that my values of A and B are given to three significance figures, where A and B are given or rounded to three significant figures. Part C, calculate the residual sum of squares RSS. So let's just have a look and remind ourselves what the formula is. This will be in your formula book. So RSS is equal to SYY minus SXY squared over SXX. Now this could also be worked out by doing SYY times by 1 minus R, the PMCC squared. Okay, so I could do either way actually, because I've got all the values that I need. I'm going to do it this first way here, just because I've got these exact values, whereas R, that will be like a rounded value, or it could be a rounded value. So I'll just take that out. I just need to remember that I'm using P for Y and M for X. So I'm just going to swap those letters around. So the X's are going to become, the Y's are going to become P's, and then the X's are going to become M's. So I'll have SPP minus SMP all squared divided by SMM. So now I can just substitute those values in. So RSS, SPP, from the previous section, this was the calculation I did to find SPP, and if we work that out, we get 2,863 over 4, and then minus SMP, so 1,115 squared, divided by SNM, M1, don't know how many M's I said there, so that's going to be 1846. That gives 42.2803 and so on. I want to give that answer to three significant figures. So RSS equal to 42.33 significant figures. Okay. Right, for the person who scored 30 marks on the maths test, Part D, want to find the score on the physics test. Now we have a residual here, so we're going to be using that residual from this plot of residuals to work out the person's exact score. So for the person who scored 30, so that's going to be this person here, we'll read off. So this cross here represents their residual, and we'll read off what that residual is over here. So it's going to be this value. We've got 2 divided up into 5 squares, so each square is worth 2 over 5 or 0.4. It's got 0.4, 0.8, 1.2, so that'll be negative 1.2 as the residual for the person that scored 30 on their maths test. So the calculation for the residual is the observed score, that's the actual score, actual value, minus our calculated value from the equation of the least squared regression line, and that's equal to the residual. So the observed score, that's what I want to work out. So that's going to be the physics score. I'm going to subtract from that the calculated score. In other words, I need to put 30 into this. So that'll be 1.08 plus 0.604 times 30. And that's going to equal the residual, which is negative 1.2. So basically, we just want to rearrange this to work out what their actual physics score was. Now, that's just going to be negative 1.2 plus the result of this calculation. So that will give us 19.2, or negative 1.2 plus 19.2, which will give us a score of 18. The data for the person who scored 20 on the maths test is removed from the dataset. Part E suggests the reason why. So let's find this person on this residual plot here. So this is a person who scored 20. There's the residual. So I would say that a reason for them being removed is because they have such a large residual. And I will go on to say that since the residual is large compared to the others, it's a possible outlier. Last part of the question. The product moment correlation coefficient between M and P is now recalculated for the remaining 15 students. So in other words, this person is taken out from the calculation. Part F, without carrying out any further calculations, suggests how you would expect this recalculated value to compare with your answer to Part A. Now Part A was the PMCC R, which we got as 0.970 to 3 significant figures, and we do need to give our reason for our answer. So you could say something like this, that I would expect the answer to Part A to be closer to 1, because we need to give a reason, because the remaining points will be closer to the regression line. We have effectively moved the point that was furthest away from the regression line compared to the others. And remember, we work out the PMCC. That is a calculation based on the residuals, how close each of the points is from our regression line. So we've removed that one. We'd expect our PMCC to move closer to 1, a closer or a more positive correlation.